evening, everybody, and welcome to our law school, Scott Sutherland School of Architecture joint webinar this evening on blockchain. We're delighted to see all of you, or see all of you join anyways to our participants list, our webinar this evening. It's great, and I would like to also say that this is, I'm delighted to tell you our first interdisciplinary webinar with staff members from both the law school and another school in the university, as I've just said, the Scott Sutherland School of Architecture. So that's really quite a positive development for our webinar series. As you may know, this is the third year they've been going, where the law school has been reaching out to alumni, students, and members of the community with our areas of research and expertise. And as the subject matter of tonight's webinar crosses the law and architecture, that we have got this interdisciplinary webinar. So we're delighted, and I would like to thank the participants right now, and I will at the end for agreeing to come, and also Cara and Chris from the alumni office for organizing tonight's webinar. Okay, so that's that. We've got three guests, as I say, the speakers tonight. We have Dr. Theo Dunas, a principal lecturer in the Scott Sutherland School of Architecture and the Built Environment, with a particular expertise in blockchain, the subject of our webinar, and also is interested in generative and parametric systems. From the law school, we've got David Christie, an associate dean in the law school, focusing on construction law and dispute resolution. And similarly, Dr. Joseph Mante, their research degree coordinator in the law school, who again has an interest in construction law and dispute resolution, as well as in group proceedings or class actions in UK jurisdictions. And my name is Paul Arnell. I'm the host of the law school's webinar series. So we're going to start with Theo to get with a general first question to get the ball rolling, and will help me and I hope many of you out there. Theo, what is blockchain? And related to that, decentralized ledger technology. I wonder if you could explain that firstly in layman's terms for our audience. Theo, thanks.
No, certainly we're going to try and explain everything as in simple terms as possible. A blockchain, or rather a decentralized ledger, let's start with that, is essentially a distributed computer network, right? So you have essentially a bunch of computers who have kind of agreed that they would keep the same copy of the same ledger, right? And on that ledger, you will have essentially a series of transactions. So imagine that instead of having, when I buy a coffee essentially with my debit card, right, we use essentially a centralized computing network to kind of do the transaction of buying the coffee. And instead of actually using a bank that keeps that ledger, you would use essentially a decentralized ledger technology. Now, the term blockchain comes from the fact that you are keeping every bunch of transactions into blocks, and each block contains, let's say, the encrypted version of the previous block, hence creating a chain of blocks, hence the term blockchain. I won't go too much into the kind of cryptography and the whole way how the computer network essentially kind of agrees to what is the version of the truth, right? This will be a little bit too technical, but essentially suffice to say that it's robust enough so that we can trust essentially that a blockchain network would always have the latest and true record of a series of transactions that we have kind of trusted it to work with.
Okay, thank you. Maybe it's a very simple follow-on question, but just to take your example of a coffee, for example, I mean, I don't understand how money is going to be taken from me and given to Costa. How does that work if you say we can use, instead of a card in Bank of Scotland, transferring some
right
from one to the other?
So essentially what happens is that you have an account with a bank, and Costa has another account with another bank, and you basically go onto my account and where you have essentially the record of my cash, and say, well, you're going to deduct 3 from there and then add 3 to Costa's, right? On the blockchain, you have exactly the same thing. You have accounts which belong essentially to entities, whether these are computers or humans, and these accounts will essentially have the equivalent of money, or in blockchain terms, cryptocurrency, right? So you have essentially a set number of units that we all agree that within the world of blockchain would act as currency.
Okay, I think that's a little more clear to now. So, and I guess it's just trust is the critical thing, and non erasability or non-amend, that can't be amended. Is that the key?
Exactly. So a blockchain is always a machine that goes forward in time, right? So you can't really go back and delete essentially a previous transaction. You will always have a trustworthy record of all transactions due to the nature of how transactions are recorded in each block, and essentially every block containing kind of like the encrypted version of a previous one. So you have this chain that you cannot break it essentially by going back and deleting, say, 100 blocks back in time. The other thing that kind of brings us to this is that someone would ask the question, why do we need this, right? We already have currencies and so on and so forth, right? And I have to kind of refer to the first blockchain that was created, which was Bitcoin. And the reason why this was created was because centralized financial institutions failed in 2008, and that kind of prompted computer programmers to come together and say, well, how do we come together to create a kind of transaction network that would help us avoid the kind of problems that existed with central bank institutions in the 2008 financial crisis, right? So that was the motivation behind actually, why did we actually need a blockchain back then?
So it's the permanent record. So I could never be accused of, or I could never get away with saying, well, I didn't actually have a coffee on Saturday at Costa if I in fact had, because that transaction would be forever recorded. Exactly.
And then I can also record on this. If you extend it, I can record essentially all other data that I want maintained for the, any kind of future generations.
Okay, that's a lot clearer for me now. Thank you. We'll maybe move on, and so we have this blockchain system in a certain context about architecture, engineering, or construction, industrial ecosystem that we're going to talk about construction on today. Why is blockchain particularly good for those sectors?
So the construction, we call it the AEC industry, right? But I'm going to be talking about the construction industry mainly. Is essentially a very decentralized, very fragmented industry, right? It doesn't have a lot of vertical players that would kind of accumulate, let's say, expertise or financial strength, right? And plus, the nature of every construction project is that you bring a wealth of players together, and they create a project team that then gets disbanded, and skills and project knowledge kind of gets lost until the next project. But why does that make it, make blockchain then a good fit? Well, first of all, within construction, due to its nature, a kind of, I would even say, a little bit medieval kind of nature still, right? It looks like a bunch of guilds stemming from, the 1400s. You have essentially a lot of corruption. You have a lot of problems that come from having adversarial natures in the relationships between all of the SMEs that come together. You have delays in payment, again, due to the nature of how the projects come together. And you also have a kind of fragmentation of all of the information that is needed to do a project, right? And to give an example, to people that maybe have worked only on one part of construction, right? You have, for example, the architects or the designers that do the design, and the role ends at some point, and they transfer knowledge to the next step, and then potentially things will change, or the intention of the initial project will change, and so on and so forth, right? And then you have the constructor that will come in, you have the contractor, you have the subcontractors, and all of that creates a fragmentation in terms of the information that is needed for the project. So part of the deal here is that blockchain could actually be used to create a kind of golden thread of information, first of all, for retaining a kind of A to Z or cradle to cradle record of all of the information, but also it could fine-tune a lot of the adversarial issues that we see a lot of times in the way construction projects are come together.
Thank you. And I guess what's springing to my mind, and this technology is wholly international. So often our students on our construction law course, and you're probably well aware of this, come from the Middle East, and they're working
Yes.
on construction projects which have players, maybe UK construction law companies, and other subcontractors from India, say, or something or other, but really global players, and this would get around some of the difficulties caused by the truly international nature of some of these construction projects. Is that right?
Exactly. So part of the technical, well, there is a legal side to this as well, right? Which I'm not capable of answering. But in terms of the technical side, because a blockchain network is essentially global, it allows you to move information and payments across jurisdictions, and it allows you to also fine-tune any kind of collaboration features you might need when you're working with international companies. Note here that we're always talking about a public blockchain. We're not talking about a private closed gates blockchain. If we need that, if that's a kind of special case that we may look at some point.
Okay, thank you. Maybe that leads us to our next question about smart contracts. Is that are they particularly good for construction contracts and incorporating facets of original contract law or contracts and blockchain? So maybe you can start, and then I move to Joseph. Well, and Theo, what is a smart contract?
So a smart contract essentially is a piece of code, a piece of software that we can run on a blockchain, and it is the equivalent of an automated vending machine realized in software, right? So when we essentially will insert a coin, I will get a soda out of the automated vending machine. A smart contract is exactly the same thing in the sense that you could actually program it to say, well, when all of the documentation is finished, pay the architect, right? And you can do that instantly. I'm kind of oversimplifying the example, but this is the nature of what we're discussing here. And the term contract, at least as far as I understand, it doesn't come from the idea that it is a legal contract, because you have obviously other issues to deal with, but because the coders, the programmers that came up with the concept wanted the smart contract to have the same validity or the same gravitas as a legal contract. And within the programmers kind of lore, they have the phrase, the code is the law. So what is written in the smart contract is what actually needs to happen.
Maybe that cues up you, Joseph. Then are these technological vending machines, as Theo describes them, are they real legal contracts, Joseph?
Thank you very much, Paul. And I guess building on what Theo said, Theo's perspective, as articulated, represents one of the perspective that you will find in the literature on what smart contracts are. For instance, by that perspective, they are seen as computerized transaction protocols that execute a particular instruction. And however, if you go back to some of the initial conceptions around smart contracts from people like Nick Szabo in 1994, what they actually thought of when they were envisaging this idea of smart contracts, they were looking at this computerized transaction protocol executing what they refer to as terms of a contract. And that gives an impression that there is some kind of arrangement or an understanding, a pre-existing understanding that is then translated into a code, or to put it in a simple language, a computer language, which is not the same as the natural language in which it is written. And so I will say that smart contracts have technical perspective. For the very technical construction, crypto aspects, it's a computer code. But for the legal minds thinking about what they are seeking to achieve by a smart contract, it is in substance a contract, a legal contract, and I can elaborate on why that is the case.
Okay, yeah, I think we can move on to that question now. You know, how do these smart contracts, these vending machines, interact with real contracts? And from my experience, they're these standard FIDIC and other sort of contracts of construction law that I thought were sort of model contracts, and maybe they're related to what you're going to be talking about. I'm not sure, but how do these relate from what we would say? Yeah, I would think an old-fashioned paper or legal contract and dealing with the various parties in the construction with smart contracts.
Thank you very much. As Theo mentioned, let's use the analogy of the vending machine. For those with legal background, we can easily understand that the concept of the vending machine is underpinned by an understanding, a transactional or a contractual understanding. And so from the legal perspective, you want to look at the smart contract idea and how it interacts with real life contracts from two perspectives. One, it is possible to see the smart contract as, if you like, a second level transaction. So in the first instance, the parties agree on, in principle, what is going to be the rules and the regulations governing a particular transaction, set of transactions. And this may be written or not written, but beyond that, they decide that, hang on, we want to ensure that this understanding is executed seamlessly without any interruption, human intervention. And so they decide that we want to code or translate that understanding into a code which is self-executing. Self-executing simply means self-enforceable. And in that sense, there is an existing contract, but the performance of that contract is reduced to some kind of automation so that when something happens, that triggers a reaction from the system. And that's one way of seeing smart contracts interacting with real life contracts. There is some understanding that in the near future, we may not even have that first level traditional contracts being executed and then translated into this computer language. It is envisaged that a time will come when that whole process will be done on-chain, as it's normally referred to. And in that case, you have a situation where the parties have this pre-understanding that when something is done or something is a condition takes effect, then there is a corresponding response that is triggered by the automated system. So in brief, that's how I see the smart contract interacting with the real world contracts. And of course, there are questions that or implications for envisaging the smart contract as a real life contract, in fact.
Okay, thank you. Coming from the legal perspective, I want to come back from the technical side of things. Theo, how do you see the relationship between smart contracts and so-called real world contracts? What do you see the relationship being?
Well, I think my views align with what Joseph was describing, right? So you need essentially to have a legal contract in the sense that you need to have a general agreement between the participants about what needs to happen in a project. And that is going to be needed even if you didn't have a legal contract and you only went with trying to write a smart contract and kind of predicting the outcomes and say, well, if this happens, then we need someone to get paid or we need someone compensated, right? So you need to kind of initially I'll speak from the perspective of someone who kind of designs smart contracts, right? You need to essentially very carefully preconceive all outcomes, if you will. or preconceive all outcomes that this particular contract or smart contract is going to do, and then assign to each participant or whether we're talking about code, to the code of the particular actions that need to happen for each outcome, right? And normally a lot of these have to do with payments, but they might also have to do with custody of keys in terms of who has access to which part of data and which who doesn't have access to that. So that sometimes these might raise, I mean, a classic problem with blockchains is the general data protection and how you can kind of keep the two aligned when you can't actually delete things from a blockchain. So what you do is you don't actually keep the data directly on the blockchain, you only keep the cryptographic signatures, if you will. Right? So you're kind of you're able to prove essentially on a smart contract that a particular piece of documentation existed when you needed it to exist. So, you know, you're trying to figure out a way to craft a piece of code that will be compatible with what the legal contract you have predicts, and also to have it, the way I understand it, have all of the outcomes of the smart contract be compatible with the legal system that you're operating under, or you're assuming you're operating under.
Oh, that's very, very interesting. So in a way, it's crystal ball gazing, I suppose, in some senses. You look at possible outcomes if somebody's in breach or somebody's late in payment, or somebody doesn't, the quality isn't good enough, or whatever a term which should be in a contract is predicted. And when that happens, it triggers an outcome under smart contract, so far as I understand it. Thank you.
Exactly.
Well, Paul, before you go on to the next one, just chip in very quickly. If we reduce it to, let's say, the legal terminology or phrase, meeting of minds, that's the starting point. I don't think there is any suggestion when it comes to smart contracts that the origins of the idea underpinning the transaction is also from the technology. It's more, it's easier to see it this way, that there will be meeting of minds before whatever understanding is translated into the code. And so whatever is happening in the code essentially is a reflection of what the parties have already understood to be the underpinning principles of the transaction. And that's another way of looking at smart contracts and how we are discussing. Essentially, it's the mind of the blockchain, the ledger system, and it controls the transactions.
Okay, thank you. Because one of the things that sprung to my mind is I wonder if that's, you know, going to take away from the autonomy of the parties to negotiate and come to an agreement as they see fit, if it's somehow dictated by a smart contract. But you're saying this would all be decided up front, and then that would be mirrored or replicated in the smart contract. I think I'm getting that right, and forgive me if I'm not. I guess one thing, I just will go back to the start again, and I see that a couple of questions have come in the chat box. So, but to all of the participants out there, please do, if you think of a question in the course of our presentation and our conversation, please do to use that, and we'll address them at the end. Thank you. We're going to move on now to payments, and I think Theo mentioned that. David, one of the key applications of smart contracts is around facilitating payment. How does the law respond to that?
I mean, that's where it's tricky, and that's where, for all that the idea of the smart contract is self-executing, it requires a degree of trust by the people who then enter into it that it's going to work. So, you know, ideally, everyone thinks it's great, and we enter into the self-executing piece of code, and that makes the payment when it should be on the terms agreed. Obviously, that means that parties are going to be handing over quite a lot of power to an automated system, and there are problems with that. But just stepping back, one of the key things about construction industry smart contract is that, for all that it's an international industry and there's lots of parties all over the world, and that the blockchain can facilitate trust across, you know, those international networks, all construction projects by their nature happen in a place. And that's why the use of blockchain in construction is distinct from the use of it in finance and use of Bitcoin and whatever, because there is decentralization of the blockchain, but there is a centralized place in which the construction happens. That means that the construction project itself will be, to some extent at least, governed by the law of the country in which the project is happening. And it's interesting then to think about how the law interacts with smart contracts and blockchain. Payment mechanisms are already just about, if not able to be done technologically. But if they happen in the UK, then they would interact with existing contract law and with legislation which governs payment processes in UK construction industry in the form of the Housing Grants Construction Regeneration Act of 1996 as amended. And what's interesting when we look at these three distinct abstract concepts, or relatively abstract concepts, of the smart contract, the standard form of contract or the bespoke contract between the parties, and the process in the legislation, is that they all, to some extent, what Theo described as being an attempt to deal with preconceived outcomes. All of them form a degree of flowchart. You could reduce them to a flowchart of processes where one thing happens and then something else happens, and if that doesn't happen, then another consequence occurs. So you see then a series of processes growing up almost in parallel with each other, and then the question is, how do they interact? So at the abstract point, the 1996 Act, which I just mentioned, was aimed at ensuring a degree of transparency, and with that transparency, trust in the UK construction industry around payment. Blockchain, basically, for its proponents, is said to create transparency and trust. So these should be complementary, and the question then is how you make them work together. And that, I think, is perhaps when you come into some of the challenges. Before I get onto that, those challenges, though, the question would be, does the Act apply given how decentralized everything is? And I think looking at the current state of the case law, the courts are keen to take as wide a reading of the application of the Act as they reasonably can on the words. And the question is does it relate to construction operations? And that's a very broad test. Okay,
thank you. I think we're going to move on to the legal challenges just right away. But I guess from my simplistic understanding about this, when there was a contract in construction law, one of the most important parts of it would be the governing law. I mean, is there a governing law in a smart contract? Say this, in the case of dispute, it will be English contract law that will discover it. I guess that's my first question. And the second one, what are the more generally the legal challenges that could arise when concluding a smart contract? David, please.
Yes, on the governing law, I mean, as with any contract, the parties can agree the law that governs their contract, they would agree. The smart contract question is there a governing law of a smart contract? That depends on what you consider a smart contract to be, as Joseph was saying, whether it's a tool or whether it's actually something that reflects the parties' agreement, and the way in which you would deal with that is different. The payment legislation in the UK applies to work that's done in the UK, whatever the governing law is, if I recall correctly. But one of the challenges you have generally, to come on to the challenges of the smart contract, is enforcement. One of the things that people understand with things like Bitcoin is that people can be anonymous. And so there is a challenge on how you keep hold of the various parties to the smart contract in a way that you can enforce the obligations against them. Now, to some extent, that's okay with construction operations, because there is always going to be stuff in the place where the construction work is being done that has some value that can then enforce against. But there will be issues about who the contracting parties are and how you make sure that they do what they're supposed to do. And that is something that's recognized. I suppose the benefit is that by automating payment or making payment more straightforward, you have a degree of security and transparency through the blockchain over payments being made, and it becomes less important to know exactly who is making the payment if you know that you're going to get the payment. The other point is about how you link payment to what is happening in the real world. Because as Joseph said, the ideal with a smart contract is that it's self-executing. But if it's self-executing, you don't want to lose control completely over what's going on. So you need to find ways of translating the real world progress of the works to the point at which payment gets made. And this is a recognized problem in blockchain and smart contracts. It's called the oracle problem. What are the oracles which translate real world into the blockchain? One of the things that is useful in thinking about that then is the process in the 1996 Act, because it in itself creates a series of what we might think of as oracles in this context, but obviously weren't considered that at the time, through the provision of requirements for parties to provide notifications of what's going to get paid and when, and then also to provide transparency that if they're not going to make payment, then they say how much they're not going to pay and why. So that process, I think, is instructive if we're thinking about using smart contracts to build in these ways to ensure quality information is translated appropriately into the smart contract, which can then identify what's going on and make payment as required, or put in necessary safeguards to prevent undue payments being made. One of the quotes you often see then is garbage in, garbage out. And so what you need to make sure is that good quality inputs are then met with high quality outputs.
Okay, thank you. That's very, very interesting indeed. I mean, how this 1996 Act has come to be applied and still apply to some technology that was not foreseen, or could probably not be foreseen, way back in the olden days of 1996 when it was enacted. I'm going to move back to you, Theo. I mean, I understand that you and your schools developing some expertise on blockchain at the university, and I know, and I think, forgive me, I forgot to mention at the outset, you edited a recent book published last year by Springer on blockchain and construction law, and it includes a chapter by David and Joseph. So well done for that. But I wonder if you could just tell us a bit about the expertise developed at RGU on blockchain for construction.
Thank you for the nice words about the book, right? And I think it's a nice kind of output of all of the work we've been doing in the past 4 to 5 years, along obviously with also Joseph and David. I mean, the interest here started more so not from the payment perspective, but actually from the idea that with blockchain we could create a kind of golden thread of information for all construction projects, right? This was my motivation essentially to look into it. And there were also other kind of desirable characteristics, including that is essentially a kind of anti-corruption mechanism, but also a technology that can that acts essentially against censorship, right? So it has many applications beyond essentially the architecture, engineering, and construction industry. So the whole thing started almost just as I arrived in RGU. Before that, I was in the university in China, and we're looking at blockchain as one of the technologies that would essentially develop as one of the key points in the fourth industrial revolution. We won an award in a competition in China, essentially designing a blockchain city for the Chinese government. We only won the third award, so it won't be built. Unfortunately, it wasn't the first. But that also gave us the kind of incentive to go into exploring the technology on a much lower level. So we were very thankful to the university in receiving a Priming Fund Award. And with that, we started kind of prototyping and developing our own expertise in writing smart contracts and developing the first smart contracts that we could use to showcase feasibility, essentially. And this is how also we started discussing with David and then Joseph as well on what was the legal side, because obviously I was finding a lot of references in terms of legal framework, but in classic fashion, I'm not a lawyer, so I needed that help essentially. And that kind of jump-started our whole process of essentially creating a group that looks into those kinds of things. From the perspective of the Scott Sutherland School, we're developing prototypes, right? And we're I think on a really good level at the moment technically to implement even those prototypes. And to kind of showcase our expertise, we thought the idea of writing a book and editing, dealing with a wide range of subjects in blockchain for construction, right? So from coordination to payments to building information modeling to the legal side, just so that we can kind of establish our authority on this. And at the moment, we're developing a couple of research applications for this. but also we're very much welcoming any kind of collaboration, both from the construction side, but also from the legal side of construction, in terms of questions that people might have, or they might have an idea they want to implement. So you can find us online, and we can have a discussion.
Excellent, excellent. Thank you. I think we're coming to our last question, and I see maybe its timing is about perfect. We're getting 5 or 6 or more questions so in our chat box. So we'll come to those just after our last one. But this is maybe looking forward to the future. Theo and then David, what do you see as the vision for blockchain, a blockchain-enabled construction industry? I suppose. How do you see this? I think moving forward. Maybe we'll start with you, Theo, then move to David.
So the way we kind of understand a blockchain-enabled construction industry would probably mean that we have at our hands an industry that is much more productive, is much more integrated than it is at the moment, a lot less adversarial, where you make the contracts work without needing to always think, when I'm going to be found at fault or stuff like that. And then when you kind of see essentially the blockchain and kind of addressing key features of how you get into really productive collaboration, which is aligning financial incentives and aligning, creating transparency in that sense. And I think there are also a lot more kind of innovative features that we have also prototyped, and we're looking forward to testing, where, for example, you can assign financial incentives in being trustworthy in a series of projects, or assigning financial incentives in reducing carbon or reducing waste in a construction project that becomes even more pertinent with the climate change and the situation with the environment at the moment. So it can kind of create a much more, let's say, positive environment where construction really moves into the 21st century. Excellent.
Thank you. David, do you want to give your legal perspective on you see the vision for
Yes.
enabled construction industry?
Yeah, and it's the slightly more down to earth view of the sunny vision of people all working together, because as a lawyer you see that people don't always work together. But where the opportunity comes with the blockchain is to change, as Theo mentioned, some of the commercial incentives, so that if you make payment automatic, unless something happens that moves the ability to make payment from the employer to the contractor, or is the employer stopping payment rather than having to actively take steps to make payment, and that can be very useful in terms of the commercial relationship. In terms of legal concepts, if you're looking at creating various value tokens outside of conventional money, if it was something based on decarbonization or something based on essentially incentivizing good behavior or rewarding trust, then it's how do you create the legal structure in which that happens. And for example, to go back to the 96 Act, there's a process there where at least there's transparency over how money is allocated and how money is taken away. Maybe you need to think about those sort of processes in dealing with Trustcoin or other forms of cryptocurrency in that area. In terms of the immediate uses, blockchain, I think, can support things like cash retentions, and reform of cash retentions is something that's quite high on the policy agenda and construction law in the UK, and something where the payment of cash retentions becomes more automatic, maybe not fully self-executing, but more automatic would be very helpful as an immediate goal. And then there are a whole host of obviously legal issues all the way, depending on exactly what it is you're doing. Things like copyright, where design is shared on the blockchain and so on. I suppose the big opportunity as well is in terms of the way in which information is gathered and managed. At the moment, compared to even 20 years ago, the amount of information that you can store about what's going on a construction site has increased exponentially, and the ability to capture that in a way that then is accurate and you can trust, because that it is what it says, means that when it comes to resolving disputes, every party will have much better access to much more information than they maybe had in the past, and the blockchain can ensure that information is stored very effectively. And I think that's really what underpins the sunny vision of Theo, is that disputes will become less easy to have because there will be something closer to the objective truth available to parties more easily than it was before.
And absolutely agreed. settled record. Yes, Joseph, please.
Oh, if I may chip in very quickly, I think there are very interesting developments ahead, looking at the blockchain discussion. All through, let's say, the past decade, there have been efforts to incorporate technology into construction. So even though today we are discussing blockchain, that there is that understanding that construction is at that stage where we need to incorporate technology to make certain things easier. So issues like transparency, data management, information management, things around trust, all these issues are being discussed at a governmental level, not just at the private level. So the construction playbook by the UK government, for instance, takes the issue of incorporating technology into construction very, very seriously. Then on the legal side, just to add a few points to what David said, I envisage that as this idea takes gets a lot of traction, we will have more legal questions. For instance, the status of the smart contract. Those who are drafting the smart contract and those who are thinking about the legal transaction or the legal understanding underpinning the smart contract will need to, there will have to be some consensus in terms of the status of the smart contract. At the moment, we know, like the internet, you can have it wherever the infrastructure is and you can operate it. But there will come a time when the smart contract idea will probably have to mimic what we see in the standard form contracts, where they try to create a system which incorporates the laws of the various jurisdictions to show that, to ensure that they can operate without any legal ramification. So there are a lot of things that perhaps we can look at as we look into the future. Thank you.
Thank you very much, Joseph, and everybody for answering my questions. And now we've got a number in the chat box, in the question Q&A box, and I'll 14. So I don't know if we'll be able to get to all of them. There's quite a number, but we'll start at the top and I'll see how we go. And I think whoever feels particularly able to answer, we can chip in, and then another person can as well if they would like. A first one: if we can't achieve these aims and goals with centralized governance and systems, what do decentralized systems offer that centralized systems don't? It's hard enough to get any stakeholder in the chain to do the basics, never mind a complex technology, especially given that there's a tremendous lack of computer skills in the industry. So I don't know, that's maybe somebody on the ground there. Theo, do you want to come in firstly and say what aims can a decentralized system offer that a centralized system doesn't?
Well, I think the idea here is to try and understand when is better to have a centralized governance and a system, when it's better to have a decentralized system, as in blockchain. What blockchain brings to the table is, if designed correctly, obviously, is a financial incentive alignment, but also an incentive that potentially comes, incentive alignment that goes beyond just the finance. So the reputation or trust tokens we talked about earlier is a good example. This is a good fit for the construction industry, mainly because of its fragmentation and natural decentralization, because you have very many small players coming together essentially to create a project, compared to other industries like say the automotive or car industry, where you have vertical integration with really huge companies that kind of dictate essentially what will happen with the project. So I think it's incentive, financial incentive alignment that makes decentralized projects better when you have also a fragmented kind of industrial landscape.
Okay, thank you. Maybe we'll move to the second question. Who writes smart contracts? Do they have a global standard, or better to say centralized, or can they be written by anyone the needs of the situation?
Well, if you're asking in terms of, so the people who write smart contracts are called smart contract developers or smart contract engineers. The closer looking profession would be, I would say, initially a software developer, but actually what a lawyer does on writing a contract looks very similar to what a smart contract developer would look like, right? So you're kind of trying to work within certain rules. There are no global standards. It's an emerging technology, right? So you have essentially certain blockchains that have become, let's say, much more dominant than others. The more common one, and we'll see also now a question later about Solidity, right, is the Ethereum virtual machine, which is the most common type of blockchain that you can run smart contracts on. And the more common language that people use, when I say language, I mean computer language, is Solidity. But you can also write them in any other kind of computing language that could run on a blockchain.
Okay, thank you. This is an interesting question that aligns with my sort of thinking. I wonder how popular this actually is in the real world. What's the current adoption rate of blockchain technology in the construction industry for enhancing trust, avoiding leaks, and standardizing processes? Is this getting increasingly widespread, or is this just a niche thing just now? What's the current adoption rate? Is there any stats on that, or do you have any information on that?
At the moment, I would say it's a niche technology that we're probably looking at an ever expanding use. I'm not aware of any projects that have used it for payments yet, apart from experimental projects like ours. But they have used it in HS2 down in England for timestamping files and securing essential information. So, and there are a couple of other cases in Scotland where they use it essentially for cybersecurity and validation of information.
And there are at least a prototype, and I think it might be one step beyond that in terms of some cash retention and project bank account systems. Where the blockchain supports those.
So it's fair to say it's an emerging technology. Is that a fair assessment?
Yep.
Absolutely.
There's another question about how being permanent record. How will a long-term smart contract deal with changes in legislation, for example? So we have something, and then there's another amendment to the 1996 Act or something changing the law. How would that the question author writes, I doubt it will be able to facilitate this unless you compromise the entire point of the system itself by making it open to change. Is that sort of, how do you respond to that?
There is, I mean, it's a nice question, and it's technically, I mean, smart contracts essentially, the moment they are deployed, are immutable. So you can't go back and change what's written in them, right? But what you can do, and this is now a nice kind of technical solution that addresses a legal problem, is to use a proxy smart contract. So let's say we enter into an agreement through a legal contract, and we agree that the current state of the smart contract is always at this particular address. So we mention an address, and this acts as the proxy of what is current. But you can't really delete the contract, but what you can do is you can deactivate it and activate a new one. So if you're having let's say a construction project that lasts for 10 years, that means that you might need to change essentially certain aspects of how a project gets executed. You might start with a smart contract that deals with the first 3 years, and then you deactivate that one and activate a new one at the proxy address. So there are technical solutions that allow you, if there is consensus off chain, to achieve consensus on chain as well.
Oh, just to add a few sentences. Yes, and I think this is a very, very important question, given that perhaps one of the key features of a new construction project is change. And so in building a system which runs and regulates a transaction, a construction transaction, it must intuitively take account of the process of change that is often built into many construction contracts anyway. So for instance, if you take the FIDIC or the NEC, there are clear rules on how you go about variations assuming that they occur. And so as the technology develops, some of these changes can be worked into the system. And as Theo said, the technical bit is also developing. So once the individuals conceptualize how they are going to deal with changes, the technology can take care of that and input it into the system.
And just finally, I mean, there is a challenge for policymakers when they come to be regulating areas that may be governed by smart contracts to think how the regulation would operate in that sense. But as Joseph says, construction projects are always subject to change across a whole host of things, including changes to the underlying law of the contract after the contract is signed, and people seem to cope.
Right, so that's maybe nothing new. The laws had to deal with that. I guess over the centuries, I suppose, a new statute governing an issue. This may be a particular sort of just a detailed question. How would payless notices work in this instance? Payless notices.
So under the Act, there is provision made for the employer to serve a pay less notice if they don't want to pay the full amount that is certified that they should pay. And one of the things that we're raising with this talk tonight and in our book chapter is that this is an issue that people thinking about smart contracts need to be aware of, because the smart contract has to take account of the fact that the law says that a pay less notice should be served. So some sort of communication will need to happen, but that will help in terms of ensuring that people involved in it have access to, the law there provides a safeguard for the employer. There could be a way to make sure it's generated in a way that was covered in the Act. And I think we talk a bit more about it in the book chapter. So I won't take up time, but plug the book chapter.
Okay, yes, and that's available. I think, well, I would say on our library, but want to sell a copy or so. Springer Publishers and Theo's book, and can find details on that on his entry on the RG website. I guess now, and this is to something that Theo mentioned earlier. How much time is required to learn a Solidity language, Theo?
If you're a little bit experienced with programming, I think you would be able to deploy your first smart contract maybe within a week or even sooner. To have a good command of a language, you would need something like 2 to 3 months. If you're completely novice, so let's say you haven't programmed a computer before, I think you will need something between 6 months to a year until you are, proficient. But it's not a difficult language to actually learn. It's more about wrapping your head around running your code essentially not on a single computer, but on a network of computers and whatever all that brings into the table.
Okay, thank you. I think we'll have just a couple more questions. We're just about at 6 o'clock. Here's one that maybe would be concerned with all of cybercrime and various people's concern about the internet and the safety of things. And I know we were mentioning at the outset that the great benefit of the blockchain is this immutable permanent record. But do you have any concerns about foul play between parties involved in a smart contract? Like a loophole that allows one party to submit low quality work and still receive their payment, or the opposite, where payment can be held back regardless of the quality of the work?
Absolutely. I mean, on a technical level, this is what David was discussing in terms of oracles, right? So you need essentially trustworthy entities outside the blockchain that will make sure that the information that we're feeding the smart contract with is true, trustworthy, and of the agreed essentially quality and requirements. A lot of the ways that we're dealing with, let's say, the digital architecture of a project that uses blockchain does not come within the kind of requirements of the smart contract, because a lot of times it's very simple, but deals with whatever happens outside essentially the blockchain. How do we feed information to it? So yeah, this is a major issue and concern on how we will adapt essentially certain processes so that we can take advantage of the trustworthiness and financial incentives of the blockchain.
Okay, and then we got one final question, and I think you alluded to this earlier, Theo. What will be the difference from the legal perspective, and I guess more generally, for a private and a public blockchain? I don't know if that's a legal question or a technical question. I don't know who wants to volunteer. The question is, what will be the difference from the legal perspective for a private and public blockchain?
I can tell you what the technical difference is, and the difference is that on a private blockchain, no one who is not participating on that private blockchain has access to the information, and that's the major difference. And obviously, that has legal ramifications of what you can do and what you can't do with that information.
Just from a legal perspective, aren't these all these big construction law contracts? They're secret as between the parties. They're not public. You don't want the public or your competitors to know the terms of your contract, do you? You know, so what they would all in construction, they would all be on a private blockchain. Joseph, was that right?
Yes, Paul. As Theo said, the key distinction is who sees what, and for private blockchains, just as it is with private contracts, where you have parties dealing with a project, and only the parties and the entities involved in the execution of the project see what is going on and share information in relation to the project. The same principles will apply here. And for instance, if there is a transaction that involves a client, a major contractor, and an architect, or let's say the engineer, then those are the parties who are interested in what's going on, and so they will be the parties who have access to the information, basically.
Okay, well, thank you very much. This leaves me time to say goodbye and thank you, and to tell our audience that the webinar has been recorded, and in due course, we will be letting you know, and the alumni office will be letting you know about where to find that recording on YouTube, I think. And I'm sorry we haven't been able to address every single question, but if I can be so bold, can I volunteer our participants and say that if you haven't had your question answered, I'm sorry we ran out of time, but I imagine they will be so kind to answer an email you would send them about a question you had. So please feel free to do that. So finally, I guess now I say Theo, David, and Joseph, thank you very much for taking part this evening. I found it very illuminating and fascinating, really, and delighted to hear that our university and our two schools are on the cutting edge of this emerging technology and heading for hopefully good and great things in the future. And finally, Cara and Chris from the alumni office, thank you very much for facilitating the webinar this evening. Thank you very much, everybody. Good night.
Thank you, Paul. Thank you everyone for coming.
Thank you.